The last video, we learned about implicit casting. It's when the compiler will cast a variable inside into a bigger one, knowing that you won't lose any information, knowing that if I put this one inside there, it could contain that value. And this was called an implicit casting, where the compiler does it for you, knowing full well that you're not going to lose any information, so no loss of information, right? Now, we knew this was possible because we knew the size of our variable types, right? We knew that, let's say, an integer, which was a 32-bit, could fit inside of a long, which is a 64-bit, right? We knew that because it has the size. And because of that, the compiler would be okay with putting that inside there, the value, whichever it is that it contains. Now, on the other hand, we couldn't implicitly put a long value inside of a smaller one, such as int. We couldn't put a 64-bit inside of a 32-bit because there's going to be a lot of loss of information. Actually, it's even worse than that. There's an error, and we're going to learn about that error right now, but let's try this out. We're going to learn about that error in a second, okay? We'll come back to that. So to be able to do this casting from 64 to 32, we have to tell the compiler that we know for a fact we're going to lose some information and we're okay with it. So we're kind of going to do this thing we call an explicit casting. So let's go ahead and try this out. We're going to, again, choose long in this case. So we have a big number. Let's create a big number. So I'm going to say 1. The underscore, again, is there just to make it easier for my eyes to see how many zeros I got. I don't really remember what was the maximum, but I think this is more than enough for an integer, which can contain this big of a number. So again, this is 64 bits, right? And we have an integer, which is a smaller number if you compare it to the long. So in this case, we want to put big number in here, but notice that when I try to put the big number inside the small number, implicitly it cannot do it. It's saying, hey, I require an integer, but you gave me a long. It knows that long is bigger, so it won't do it for you. But you could explicitly cast that by putting a parentheses in front of what you want to cast. So in this case, I'm going to say in front of it, I want this to be changed into an int. But again, we have a problem that's going to happen. So let's check it out before I tell you more. So we're going to say big number here, and let's go ahead and print the small number. And when I'm going to run this, the error that we're seeing now is called a type overflow. So it has something to do with binary. When it converts those 64 bits into 32 bits, we get some problematic values. This is why you shouldn't, if you can, you shouldn't do any explicit casting unless you know for 100% that it's going to be okay. Right? And we're going to give you some examples that we could define as okay, let's say as an example. Right? So over here, this big number, when casted to this small number, this explicit cast, we got this really weird number with a minus. And again, this is a binary issue. Maximum number of of integer, we could see that by doing integer max value here. We put our mouse over it. Our max value is this, right? This is our max value. We'll talk about how I got this later, but for now, the max value of an integer is that number over here. But you could see here, rather than taking the max value, it took a negative value. And this is a problem with the binary trying to fit it in, okay? And again, this is called a type overflow. So what I mean by this is if I take off that 1 0 over there and I press play, you'll notice that the number again is going to be completely different because the bits are completely messed up when it tries to convert it, right? It just doesn't know how to do it, and it's not easy for it. So it's just gonna keep getting weird until we reach a number. Until we reach a number. I don't know how many I need. This is 3. Let me make this a bit cleaner again. We put these underscores to make it a bit more readable. So notice here I need 9 zeros and the 10. So this is the 9 zeros. We could take off these 2 zeros. This should be fine. It's under 1 million, right? So now you could see it fits perfectly because the long number, even though it has the size of 64 bits, it's not utilizing the full amount of its size. So it could perfectly be casted. But the moment I go a bit over, so let's say I go 3 billion and I press play, again, we're over that number and we get a type overflow issue. So here, type overflow is our problem. Now, in cases that this might be okay to cast, you always will have to do the final decision and judgment call yourself. Could be that maybe you've put the age of someone and you divided the 12 months in there. So let's say you have a float and let's say this is age and let's say age in years, okay? And he's, let's say, 4 years and he's 4 years and let's say 10 months. Well, if you put 10 here, it doesn't really match 10 months because after 12 months, we get 5, right? So every 12 months, your age goes up by 1. So 10 here doesn't represent that because we could go up to 100, right? So what you got to do is represent that 10 inside of a inside of a value between 0 to 12. So basically, we got to basically do 10 divided by 12, right? And 10 divided by 12, let me take out my brain. My brain is not fully functional. So let me get out the calculator. 1 second. So coming back with my calculator, 10 divided by 12 is 5/6 of a value. So it's 0.83333333. Okay. Just hopefully I got enough threes. I'm going to just put some underscores again to make it visually appealing for me to be able to read. Now this is a floating number. A float could have around 7 precision. So 1, 2, 3, 4, 5, 6. We're going to probably lose a number. Let's try this out. I don't really care at this moment. We can make it a double, but stay with me for a second. We're going to do age in years just to see what value is going to be printed. So yeah, we lost a bit of precision because float can't contain it. Let's make it a double. This should have enough precision so that this is a floating problem. We're not going to go into that. That's another issue. So let's bring it back to float. We're going to ignore that for now because this is a more complicated issue. There's books on that. We're not going to talk about that for now. So let's say this is 10 months almost, or approximately 10 months out of 12 months, right? In this case, if I convert this age in years, I convert it to an int, and let's say this is the age and full numbers, and we put the age in years, again, we get the issue that implicitly I can't do it, and I explicitly cast it to an integer. This should be fine. Why is that? Well, because the loss of that 83 does not matter, because that person is still 4 years old. It didn't reach the maximum of that 12 months for that person to become 5 years old, right? And in this case, this casting is perfectly fine because we know the age will never reach a value that's going to overflow, it's not going to have any type overflow, right? Actually, we could go ahead and bring that over here. I'm going to bring that down, right? And because of that, this is a correct explicit casting. Cool. Now, mind you, some new people, what the issue I see is going on is you might start putting all these castings yourself for all the implicit casting. Yes, you could do that, but your cleanliness of code is going to be problematic. Okay, so don't do this unless you're doing an explicit casting and you are sure that your explicit cast will not bug your program, because these are common issues, simple issues that happens in big applications which cost a lot of money. Cool. One last point to point out is that we have the infamous. We have the infamous boolean. Am I happy? Well, not with this type overflow, so I'm going to say false. Can I cast that now knowing that I have this explicit casting? Cast, I don't know, let's say boolean, and we're going to say, am I happy? We get the normal implicit bug saying, hey, you gave me a boolean, but I require an int. And if I go in front of it and I put the cast and I say int, and then I run it, it's still giving me a compiler error where it says inconvertible types cannot cast boolean to int. It cannot understand what false should be. Again, maybe in some languages you'll be able to do this, but this is already wrong, right? Be wary of doing explicit casting. It's something being overused, and you should only use it when you know for a fact that this is not going to go outside the range that you require. It's not going to give you a type overflow, and it's not going to give you a value that you're not looking for. Notice that here, it didn't round it up. It just removed completely whatever was left over, whatever was extra, whatever it could not contain. So this is an important thing to note and understand. Thank you guys. I'll see you in the next video.